Imagine waking up one day to the news. Scientists have discovered a way to travel faster than light. Sounds like something straight out of science fiction, right? But what if I told you that some theories suggest it might actually be possible? What if we could reach another star in days instead of centuries? Could we bend space, create wormholes, or ride a warp bubble like in the movies? Or is light speed truly the ultimate limit? Today we're diving into the mind-blowing possibilities of faster-than-light travel, and trust me, you don't want to miss this. Ready? Let's go! The speed of light. Hey, have you ever wondered why we're stuck crawling through the universe at such slow speeds? I mean, think about it. Our fastest spacecraft takes thousands of years just to reach the nearest star. But then we hear about the speed of light, the ultimate speed limit of the universe. So why can't we just press the gas and zoom past it? Well, it turns out Einstein had something to say about that. His theory of special relativity tells us that as you get closer to the speed of light, 299,792,458 meters per second to be exact, things start getting weird. Your mass increases, time slows down, and eventually, it would take infinite energy to push you past the light speed barrier. Yep, infinite. That's more energy than all the stars in the galaxy combined. Now, you might be thinking, okay, but what if we just built an engine that's ridiculously powerful? That's the problem. No matter how much fuel or thrust you have, you can't outrun light. It's like a game with rules we can't break. And if we somehow did, weird things could happen, like time travel, causality-breaking paradoxes, or even physics itself collapsing. But hold on. Before we lose hope, some wild theories suggest that maybe, just maybe, there is a way to cheat the system. Enter warp drives and wormholes, two mind-blowing ideas that could rewrite everything we know about space travel. So, is faster-than-light travel possible? Let's talk about the crazy ideas that just might work. Theoretical possibilities. Alright, what if I told you there's a way to travel faster than light without actually breaking any laws of physics? Sounds crazy, right? But that's exactly what some theories suggest. Instead of moving through space, what if we could bend space itself? That's the idea behind the Alcubierre warp drive. Imagine a spaceship that contracts space in front of it and expands space behind it. The ship itself doesn't actually move, it just rides a wave of space-time, kind of like a surfer catching the perfect wave. The best part? Since you're not technically moving through space, you're not breaking the speed limit. But wait, you ask, why aren't we already building one? Well, there's a small problem. The warp drive needs exotic matter with negative energy, something we don't even know exists yet. Oh, and if we did find it, you'd need the energy of a small star to power the thing. No big deal, right? Then there's the wormhole idea. Instead of traveling across vast distances, why not create a shortcut? If space-time is like a folded sheet of paper, a wormhole would be like punching a hole straight through it. Instead of taking millions of years to reach another galaxy, you'd just step through and be there instantly. But surprise, surprise, wormholes also come with their own problems. They might collapse instantly, they might require impossible physics to stay open, and worst of all, they could be unstable portals of doom that rip apart anything that enters them. Fun, right? So, while these ideas sound straight out of sci-fi, scientists are actually exploring them seriously. And who knows, one breakthrough could change everything. But for now, we're stuck playing by the universe's rules. Or are we? Let's talk about the paradoxes of FTL travel, and why it might break reality itself. Challenges and paradoxes. Alright, let's say we somehow cheated physics and found a way to zoom past the speed of light. Cool, right? Well, not so fast. The moment you go faster than light, you break time itself. Yes, you heard that right. FTL travel messes up cause and effect, leading to paradoxes so wild they'd make your brain hurt. Imagine this. You hop into your FTL spaceship and fly to a distant planet faster than light. From your perspective, everything seems normal. But according to an observer back on Earth, you've just arrived at your destination before you even left. How's that possible? That's the causality problem, when effects happen before their causes. Now take it a step further. What if you send a message back to Earth using another FTL signal? Based on relativity, your message could arrive before you even sent it. Think about that. Someone on Earth could get your message and stop you from ever sending it in the first place. Congrats, you've just created a time paradox where reality contradicts itself. Welcome to the Twilight Zone, and it doesn't stop there. Physicists have proposed something called the grandfather paradox. What if FTL travel allowed you to go back in time and, let's say, prevent your grandfather from meeting your grandmother. You wouldn't exist, but then you wouldn't have been able to go back in time in the first place. These paradoxes aren't just annoying thought experiments, they tell us that something fundamental about FTL travel doesn't fit with our understanding of the universe. So, unless we find a way to rewrite the laws of physics, breaking the speed of light might just be the key to breaking reality itself. But wait, there's something even weirder at play. Let's talk quantum mechanics. A glitch in the speed limit. Okay, if faster-than-light travel is impossible, then someone needs to explain what's going on with quantum entanglement. Because in the quantum world, things seem to break the rules all the time. Here's how it works. Imagine you have two particles, one on Earth and one on the other side of the galaxy. If these particles are entangled, changing one will instantly affect the other, no matter how far apart they are. Sounds like instant communication, right? Well, not exactly. Even though this connection happens faster than light, it doesn't actually transmit information. You can't use it to send messages or travel through space, at least not in any way we currently understand. Einstein called this spooky action at a distance, and honestly, even physicists are still scratching their heads over it. But here's the interesting part. Some researchers believe quantum entanglement might be a clue that the speed of light isn't the absolute limit after all. What if our current understanding of space and time is just a piece of a much bigger puzzle? What if the universe has hidden shortcuts that we just haven't discovered yet? Some scientists have even suggested that quantum mechanics could be connected to wormholes, tiny microscopic ones that constantly open and close in space-time. If that's true, could we one day scale them up and turn them into real, usable wormholes for space travel? It's a long shot, but hey, so was flying once upon a time. One thing's for sure, the more we dig into quantum weirdness, the more we realize that reality is way more mysterious than we ever imagined. But what does all this mean for the future of faster-than-light travel? Is it just sci-fi, or could we actually crack the code one day? Let's talk about recent breakthroughs and what's next. Recent developments and research. Alright, so we've talked about how faster-than-light travel is currently impossible, how it could break reality, and how quantum mechanics might be hinting at something bigger. But what if I told you that scientists haven't given up yet? In fact, some mind-blowing research suggests that FTL travel might not be as far-fetched as we thought. Let's start with the Alcubierre warp drive. Remember that sci-fi idea where a spaceship doesn't move but instead bends space around it? Well, in 2021, a group of physicists found a way to tweak the original math, meaning that a warp drive might actually be possible without exotic matter. The catch? We'd still need insane amounts of energy, but hey, progress is progress. Then there's quantum tunneling, an effect where particles seemingly teleport through barriers instead of going around them. Some researchers believe this could hint at a way to manipulate space-time itself. If we ever learn how to scale this effect up to spaceships, we could be looking at a whole new method of breaking the speed barrier. And here's something wild. A 2019 study suggested that faster-than-light motion might actually be possible inside certain plasma waves. Scientists at NASA have even experimented with using plasma fields to manipulate light speed limits inside controlled environments. It's small scale for now, but what if it's a stepping stone to something bigger? Sure, none of this means we'll be zipping through the cosmos tomorrow, but science is all about small discoveries leading to big breakthroughs. If we can keep pushing the boundaries of physics, who knows? Maybe one day we'll look back and laugh at the idea that we ever thought FTL travel was impossible. So, with all this research happening, the real question is, what's next? Let's talk about the future of interstellar travel. The future of faster-than-light travel. So will we ever break the speed of light? Honestly, right now, it looks impossible. The laws of physics, time paradoxes, and energy requirements all stack against us. But here's the thing. History is full of impossibilities that humans eventually overcame. People once believed heavier-than-air flight was impossible. Then the Wright brothers came along. They thought space travel was just science fiction, until we landed on the moon. We believed breaking the sound barrier would destroy an aircraft, until Chuck Yeager proved everyone wrong. The point? Just because something seems impossible today, doesn't mean it always will be. The universe is full of mysteries we haven't unlocked yet, and every day, scientists are getting closer to understanding how space, time, and physics really work. Maybe one day we'll harness quantum mechanics, crack the secret of negative energy, or find a hidden law of physics that lets us leap across galaxies in seconds. Maybe we just haven't asked the right questions yet. But even if FTL travel never becomes a reality, our hunger to explore will never stop. The universe is vast, beautiful, and full of wonders waiting to be discovered. Whether it takes us a lifetime or a millennium, we're going to keep pushing forward, one breakthrough at a time. So what do you think? Will we ever travel faster than light? Or is the universe telling us to slow down and enjoy the ride? Let's talk in the comments. So, will we ever crack the code for faster than light travel? Right now, it's a mystery, but science is always evolving. Who knows? The next big breakthrough could be just around the corner. What do you think? Will humanity ever zip across galaxies at warp speed, or are we forever stuck crawling through space? Let's discuss in the comments. If you enjoyed this deep dive, subscribe to InnoVision Tech for more mind-blowing science and future tech content. See you in the next one. Imagine a planet so hot that it rains molten iron. Sounds like something out of a science fiction movie, right? But what if I told you that this is actually real? Meet WASP-76b, a distant exoplanet where the unimaginable happens. Have you ever wondered what it would be like to live in a world where metals turn to vapor, only to rain down as liquid iron? Or where the temperature is so extreme that even the toughest materials melt away? Let's dive into this fiery world and explore what makes WASP-76b one of the most mind-blowing planets we've ever discovered. WASP-76b. Let me take you on an incredible journey to a distant corner of the universe, to a planet where the unimaginable becomes reality. Meet WASP-76b, a giant exoplanet about 640 light-years away in the constellation Pisces. Now hold on to your seat because this planet has a feature that will blow your mind. It rains molten iron. Yes, you heard that right, rain made of molten metal. WASP-76b is not like any planet in our solar system, it's an entirely new breed of extreme. Its day side is so intensely hot that it can turn metals like iron into vapor. Think about that for a second. Just the thought of a planet where solid metals become gases is enough to make your head spin. What's even crazier is that this exoplanet's night side is much cooler, and that vaporized iron condenses into droplets, creating what can only be described as a molten iron rainstorm on the cooler side. Isn't that just mind-boggling? When we first discovered this planet, we couldn't have imagined that such extreme conditions existed beyond our own world. This planet is the epitome of a hellish environment, one that challenges everything we thought we knew about the universe and the types of places life could potentially thrive. Ready to dive deeper into this scorching mystery? Let's go! Extreme temperatures. Brace yourselves because the temperature on WASP-76b isn't just hot, it's blistering. On the side facing its star, the temperature soars to a jaw-dropping 2,400 degrees Celsius, which is hotter than the surface of Venus, and even hotter than some parts of the Sun. Imagine a place where metal turns into a vaporous cloud just from the sheer heat. The planet's extreme temperature is a result of its proximity to its host star, making its environment more like an oven than a hospitable place. To put things into perspective, if you were to stand on the day side of WASP-76b, you'd be facing a heat that could easily melt steel, let alone the metal used in construction. This isn't just a casual warm day, this is the kind of heat that would cook anything in an instant. But it doesn't end there. The heat is so intense that it causes elements like iron, magnesium, and silicon to vaporize into gases. These gases then get swept away by the planet's winds carried to the cooler side. The truly fascinating part? That molten metal, which should be solid under normal conditions, becomes part of a strange cosmic weather system. You can't help but marvel at how extreme and wild the universe can get when it pushes the boundaries of temperature to their absolute limits. Tidal locking. Imagine living on a planet where one side is always day and the other side is always night. Welcome to the world of tidal locking, and it's the unique fate of WASP-76b. This exoplanet doesn't spin like Earth does. Instead, it is tidally locked, which means one hemisphere always faces its star, while the other is in complete darkness. Can you imagine what that would be like? On one side, you'd be constantly basking in scorching sunlight, while on the other side, you'd be stuck in eternal darkness, where the temperature plummets to unimaginable lows. This unbalanced division creates two extremes, a blistering hot day side and a freezing cold night side. The lack of rotation gives rise to this severe split, and it's a feature scientists have observed on various exoplanets orbiting distant stars. It's a strange but fascinating phenomenon. The day side of WASP-76b receives an uninterrupted flood of energy from its star, keeping it hot enough to turn metals into vapor. Meanwhile, the night side is deprived of sunlight, causing the temperatures to drop and creating an eerie contrast between the two hemispheres. What's even more mind-blowing is how this tidal locking affects the planet's weather systems. Winds carrying hot gases from the day side sweep across the planet, and they bring all kinds of strange, alien phenomena like molten iron rains. The planet's lack of rotation makes it a place where extremes collide, and that makes it one of the most bizarre worlds we've ever discovered. Could life survive here? Probably not. But it definitely makes you think about how other planets in the universe might function in ways we can barely comprehend. Iron vapor and condensation. Now, let's dive into one of the most jaw-dropping features of WASP-76b, the rain of molten iron. Yeah, you heard that right. This planet has a bizarre weather system where iron vapor is created on its scorching day side, and then it condenses into liquid droplets on the cooler night side. This phenomenon is a result of the extreme temperature differences between the two halves of the planet. The day side of WASP-76b is a hellish furnace where temperatures are so high that metals, particularly iron, are vaporized into gases. Think of it as a metal mist swirling in the air, made possible by the scorching heat. But what happens when this vaporized iron is carried away by the planet's winds and reaches the cooler, dark side? The temperature drops and suddenly, that vapor can't stay in the air. It condenses back into droplets of molten iron. This creates an unbelievable phenomenon: iron rain. Now, if you were somehow able to stand on the cooler side of WASP-76b, you'd find yourself getting drenched by droplets of molten iron, which is a little bit more than just a rainy day. These iron droplets would be sizzling hot and dangerous, turning everything they touch into a fiery molten mess. The wind and weather systems on this planet are responsible for this process, and it's a bizarre kind of rain that defies everything we know about Earth's water cycle. The science behind it is fascinating, and it raises questions about how exoplanetary atmospheres work. Could there be other planets where different metals rain down instead of water? And what does this mean for planets with extreme conditions? The iron rain of WASP-76b is just the tip of the iceberg when it comes to understanding how wild and strange alien weather can get. Discovery and observations. The discovery of WASP-76b's molten iron rain was a breakthrough that expanded our understanding of exoplanets and their extreme environments. In March 2020, astronomers using the European Southern Observatory's Very Large Telescope made an incredible observation. They detected the presence of iron vapor in the atmosphere of WASP-76b. And just like that, we were introduced to a new world, where conditions are so extreme that metals can exist in gaseous form. This was no ordinary discovery. For years, scientists have been exploring exoplanets and trying to understand how different they could be from Earth. While we've come across many unusual worlds, WASP-76b stood out because of its unique and violent weather system. Thanks to the telescope's advanced capabilities, astronomers were able to analyze the planet's atmosphere in unprecedented detail. They found strong signs of vaporized iron and other heavy metals in the atmosphere, an indication that this exoplanet wasn't just hot, it was a place where extreme conditions could produce strange, almost otherworldly phenomena. But the implications of this discovery go beyond just knowing that iron rains on a planet light years away. It opens up new avenues for studying the weather systems of distant planets, their atmospheres, and how they interact with their stars. The ability to observe such detailed phenomena on distant exoplanets gives us a glimpse into what other extreme worlds might be out there. Worlds where rain could be made of metals, or where the atmosphere could be filled with strange gases. The discovery of WASP-76b's molten iron rain shows us how little we truly know about the universe, and how much more there is to learn. Significance. The discovery of WASP-76b's molten iron rain is more than just an astronomical curiosity. It holds immense significance for our understanding of exoplanetary science and the conditions that exist beyond our solar system. This planet challenges the very notion of what a habitable world could look like. The extreme temperatures and bizarre weather systems are like nothing we've ever experienced here on Earth. Studying planets like WASP-76b helps us understand the limits of planetary conditions and pushes the boundaries of what we consider possible in terms of extreme environments. Beyond the fascination of molten rain and scorching temperatures, there's a broader implication. It raises questions about the diversity of planets in the universe. If a planet like WASP-76b can exist with such harsh and alien conditions, what other kinds of planets are out there? What's the likelihood that there are other worlds with strange weather systems, and could they support different forms of life, or at least show us new ways of understanding how life might adapt in extreme environments? WASP-76. B's discovery also highlights the incredible advances in telescope technology. Observing iron vapor in the atmosphere of an exoplanet wasn't possible just a few decades ago, but now, with instruments like the Very Large Telescope, we're able to analyze these distant worlds with astonishing detail. This kind of research not only broadens our knowledge of the universe but also shapes the future of space exploration. So, as we continue to look deeper into the cosmos, we're reminded that the universe is vast, full of surprises and far more complex than we ever imagined. And who knows? Maybe this is just one of the many astonishing worlds waiting for us to uncover. So, what do you think? Could we ever encounter a planet as extreme as WASP-76b in our own galaxy? Or are we just scratching the surface of what's out there? Let me know your thoughts in the comments below. If you found this journey through space as fascinating as I did, don't forget to like, share, and subscribe to InnoVision Tech for more mind-blowing discoveries. Thanks for watching, and stay curious about the mysteries of the universe. Nuclear weapons possess a destructive power so immense that a single warhead can obliterate an entire city in seconds. Today, the combined arsenal held by global powers could wipe out humanity multiple times over. This terrifying reality is often hidden behind statistics and political rhetoric, but its consequences are very real. The true scale of nuclear weapons is not just measured in explosions, it's measured in lives lost, futures erased, and a planet forever scarred. When it comes to nuclear weapons, there are no winners, only survivors. Unimaginable blast power. Nuclear weapons unleash energy on a scale that defies ordinary understanding. The bomb dropped on Hiroshima in 1945 released energy equivalent to about 15,000 tons of TNT. But modern thermonuclear weapons can be hundreds or even thousands of times more powerful, measured in megatons, millions of tons of TNT. To grasp this, consider that 1 megaton could level an entire city in seconds. The blast wave alone travels faster than the speed of sound, flattening buildings and incinerating everything in its path. The intense heat generated can reach tens of millions of degrees Celsius, hotter than the core of the sun, causing fires that rage uncontrollably for miles. This immense power is why nuclear weapons are categorized as weapons of mass destruction, capable of erasing entire urban areas instantly. Unlike conventional explosives, nuclear blasts release energy through nuclear fission or fusion, processes that unleash far more energy per unit mass. This is why even a single modern warhead can cause devastation on a scale unmatched by any other weapon in history. The sheer destructive force is not just about the blast but also the radiation and heat that follow, making survival near the epicenter nearly impossible. The scale of this power forces us to confront the terrifying reality of what nuclear war would mean for humanity and the planet. Immediate human casualties. The human toll of a nuclear explosion is staggering and immediate. Within seconds, the blast wave can cause fatal injuries to thousands, if not millions, depending on the population density of the target area. The intense heat causes severe burns and ignites fires that consume everything combustible. People caught near the epicenter suffer catastrophic injuries from flying debris, collapsing buildings, and the overwhelming force of the explosion. But the devastation doesn't stop there. Radiation released in the initial explosion causes acute radiation sickness, which can kill survivors within days or weeks. The combination of blast, heat, and radiation means that even those who survive the initial impact face life-threatening conditions. Emergency medical services would be overwhelmed, and infrastructure destruction would cripple rescue efforts. Historical data from Hiroshima and Nagasaki show that tens of thousands died immediately, with many more succumbing later due to radiation exposure. The scale of casualties in a modern nuclear strike would be far greater due to the increased yield of today's weapons and the density of urban populations. This immediate human cost is a grim reminder of why nuclear weapons remain the most feared instruments of war ever created. Long-term radiation effects. Radiation from a nuclear explosion is a silent killer that lingers long after the initial blast. When a nuclear weapon detonates, it releases a deadly mix of radioactive particles that contaminate the air, soil, and water. This fallout drifts with the wind, spreading toxic radiation far beyond the blast zone. Exposure to this radiation can cause severe health problems, including cancer, genetic mutations, and chronic illnesses that affect survivors for decades. The environment suffers too. Plants, animals, and entire ecosystems can be devastated, with some areas becoming uninhabitable for generations. The infamous Chernobyl disaster, though not a nuclear weapon, offers a glimpse into the lasting damage radiation can cause. Exclusion zones remain today, and wildlife has adapted in eerie ways to the contaminated landscape. In the aftermath of a nuclear strike, survivors face not only physical wounds, but also the psychological burden of living in a poisoned world. Decontamination is a massive challenge, and the invisible nature of radiation makes it an insidious threat. This long-term impact underscores why nuclear weapons are not just a momentary disaster but a catastrophe with consequences that ripple through time and space, affecting countless lives and the planet itself. Global climatic impact. The detonation of multiple nuclear weapons could trigger a global catastrophe far beyond the immediate destruction. Scientists warn of a phenomenon called nuclear winter, where the massive fires ignited by nuclear blasts send soot and smoke high into the atmosphere, blocking sunlight from reaching Earth's surface. This dramatic drop in temperature could last for months or even years, devastating agriculture worldwide. Crops would fail, leading to widespread famine and threatening the survival of billions. The disruption of weather patterns would cause droughts in some regions and floods in others, creating a domino effect of environmental chaos. This isn't just theory. Computer models and historical data from volcanic eruptions support the possibility of such a climate disaster. The global impact of nuclear war extends far beyond the targeted cities, affecting even those countries not directly involved. The idea that nuclear weapons could trigger a planetary crisis adds a terrifying dimension to their destructive power, reminding us that their use would be catastrophic not just locally but for all life on Earth. Destruction of infrastructure. Nuclear weapons don't just kill people, they erase entire cities from the map. The blast wave generated by a nuclear explosion is so powerful that it can demolish skyscrapers, bridges, roads, and critical infrastructure within seconds. Power plants, hospitals, communication networks, and transportation systems are instantly wiped out, leaving survivors isolated and helpless. The heat from the explosion ignites fires that merge into massive firestorms, consuming everything flammable and making rescue efforts nearly impossible. Without roads or communication, emergency services cannot reach those in need, and the chaos spirals out of control. The destruction extends underground as well, damaging water and sewage systems, leading to contamination and disease outbreaks. In modern cities, where infrastructure is densely packed and interconnected, the ripple effects of such devastation would cripple entire regions economically and socially. This level of destruction means that rebuilding would take decades if it's even possible. The obliteration of infrastructure highlights the fact that nuclear war is not just about immediate loss of life. It's about annihilating the very foundations that support human civilization. Psychological and societal trauma. The aftermath of a nuclear explosion goes beyond physical devastation. It shatters the human psyche and society itself. Survivors face unimaginable trauma from losing loved ones, homes, and communities in an instant. The psychological scars, post-traumatic stress disorder, anxiety, depression, can persist for generations. Entire populations may be displaced, forced to live as refugees in unfamiliar and often hostile environments. Social structures collapse as governments struggle to maintain order amid chaos, leading to lawlessness and further suffering. The fear of radiation sickness and the invisible threat of contamination add layers of anxiety that permeate daily life. Children growing up in these conditions inherit a world marked by loss and uncertainty. Historical accounts from Hiroshima and Nagasaki survivors reveal how communities struggled to rebuild, not just physically but emotionally, grappling with grief and stigma. This societal trauma underscores that nuclear weapons don't just destroy cities, they fracture the very fabric of human connection and resilience, leaving wounds that no amount of reconstruction can fully heal. Current global nuclear arsenal. So the world today holds over 12,000 nuclear weapons, enough to destroy humanity many times over. Despite decades of disarmament talks, major powers like the United States, Russia, China, and others maintain vast arsenals, and each warhead is capable of unleashing catastrophic destruction. These weapons, are not relics of the past. They're active, ready to be deployed within minutes. The existence of such stockpiles means the threat of nuclear conflict remains a chilling reality. Even a limited nuclear exchange could trigger devastating consequences far beyond the battlefield, affecting millions of innocent lives. Countries continue to modernize their nuclear forces, investing billions in new delivery systems and warheads, which really signals that nuclear weapons remain central to global military strategy. This precarious balance of power is often described as deterrence, but it also carries the risk of accidental launches or miscalculations that could spiral into full-scale war. The sheer scale and readiness of these arsenals force us to confront the uncomfortable truth. The potential for nuclear catastrophe is not a distant threat, but an ongoing danger. Understanding the true scale of today's nuclear weapons stockpiles is essential to appreciating the urgent need for global cooperation and disarmament efforts to prevent a disaster that could end civilization as we know it. Escalation risk and accidental war. The terrifying speed at which nuclear decisions must be made creates a constant, lurking danger of accidental war. Nuclear-armed nations often operate on launch-on-warning policies, which means that a perceived threat, even a false alarm from a malfunctioning sensor, could trigger a full-scale retaliation in just minutes. Throughout history, there have been numerous documented near-misses, technical glitches, misinterpreted radar signals, or, believe it or not, even a flock of geese mistaken for incoming missiles, all of which brought the world frighteningly close to nuclear catastrophe. In these split-second scenarios, human judgment is absolutely paramount, but under such immense pressure, errors are not just possible, they're actually probable. A localized conflict between non-nuclear states could easily draw in nuclear powers, escalating rapidly beyond conventional warfare. Once that nuclear threshold is crossed, the chain of events becomes almost irreversible, as each side reacts to the other's actions, leading to a tit-for-tat exchange with unimaginable global consequences. The very nature of nuclear deterrence, which is designed to prevent war through mutual assured destruction, simultaneously carries the inherent risk of an unintended global holocaust sparked by miscalculation, miscommunication, or, honestly, just a simple technical glitch. The threat of nuclear proliferation. The spread of nuclear weapons to more countries represents, without a doubt, one of the greatest dangers facing humanity today. While a handful of established nuclear powers have maintained their arsenals for decades, the desire for these ultimate weapons of deterrence is, well, tempting for other nations seeking regional dominance or security guarantees. As more countries acquire nuclear capabilities, the global risk of their use escalates dramatically. Each new nuclear state introduces new geopolitical rivalries, new potential flashpoints, and new decision-makers who might not, adhere to the same strategic doctrines or safety protocols as the established nuclear powers. Furthermore, the more widely nuclear technology and materials are dispersed, the greater the chance that they could fall into the hands of non-state actors or terrorist organizations who might not be deterred by the threat of retaliation. The nuclear taboo, that global norm against using nuclear weapons, becomes increasingly fragile with each new member of the nuclear club. This proliferation not only increases the likelihood of a nuclear attack but also heightens regional instability, forcing neighboring states to consider developing their own deterrence and creating a dangerous escalating arms race with no end in sight. Economic costs of maintaining arsenals. Maintaining and modernizing nuclear weapon stockpiles diverts staggering sums of money that could otherwise address pressing global challenges. Each year, nuclear-armed nations collectively spend tens of billions, if not hundreds of billions of dollars on their nuclear programs, covering research, development, production of new warheads, maintenance of existing arsenals, and the infrastructure to support them. These are not just one-time expenses, but continuous multi-decade commitments that lock in immense financial outlays. Just consider what this colossal investment could achieve if it were redirected: alleviating extreme poverty, funding universal healthcare or education, combating climate change, or investing in sustainable energy solutions. Instead, these vast resources are poured into weapons designed never to be used, yet constantly requiring upgrades and oversight. The opportunity cost is immense. Every dollar spent on a nuclear missile is a dollar not spent on a vaccine, a school, or a clean energy project. This hidden economic burden of nuclear weapons is often overlooked, yet it represents a significant drain on national budgets and a missed opportunity for human development and global well-being. Thanks for watching this deep dive into the devastating true scale of nuclear weapons here on InnoVision Tech. If you found this eye-opening, don't forget to hit that subscribe button and ring the bell icon so you never miss our latest tech insights and thought-provoking content. We'd love to hear your thoughts. Drop a comment below and join the conversation. Together, let's explore how technology shapes our world and the future. Stay curious, stay informed, and see you in the next video. The universe is a vast and unforgiving place where each planet holds its own deadly secrets. Did you know that the surface temperature on Venus is hot enough to melt lead, making it the hottest planet in our solar system? This scorching fact reveals just how hostile some worlds truly are. But what if you could experience the final moments on these planets? Would you survive, or would the planet itself become your ultimate executioner? Are you ready to discover what it's really like to die on every planet? Mercury. Mercury is a planet of extremes, and dying there would be a brutal experience unlike anything on Earth. With daytime temperatures soaring to a blistering 430 degrees Celsius, your body would be exposed to intense heat that could incinerate you in moments. But the horror doesn't end when the sun sets. Nighttime temperatures plunge to a bone-chilling minus 180 degrees Celsius, freezing anything left behind. The planet's atmosphere is almost non-existent, offering no protection from deadly solar radiation or any breathable air. Without a spacesuit, suffocation would be swift, and the lack of atmosphere means there's no sound, no wind, just a silent, lifeless void. The surface is covered in craters and jagged rocks, making any attempt to survive physically impossible. On Mercury, you wouldn't just die, you'd be crushed between extremes, scorched by the sun's relentless heat, then frozen solid in the cold vacuum of space. It's a place where survival isn't just unlikely, it's impossible. A stark reminder of how fragile life is beyond our home planet. The merciless environment of Mercury is a testament to the unforgiving nature of space, where the difference between life and death is measured in degrees and seconds. Venus. Venus is often called Earth's twin, but dying there would be nothing like anything we experience here. The moment you step onto Venus, you'd be crushed by an atmosphere 92 times denser than Earth's. Imagine the pressure at the bottom of the deepest ocean multiplied many times over. Your body wouldn't just break, it would be flattened under this immense weight in seconds. But pressure is just the beginning. The air is almost entirely carbon dioxide, laced with clouds of sulfuric acid that would corrode your skin and lungs instantly. Breathing in even a single breath would be fatal, causing immediate suffocation and chemical burns. Temperatures on the surface hover around a hellish 465 degrees Celsius, hot enough to melt lead, so any exposed flesh would be incinerated rapidly. The thick, toxic atmosphere traps heat in a runaway greenhouse effect, making Venus the hottest planet in our solar system despite not being the closest to the sun. There's no shelter from this relentless inferno. The crushing pressure, suffocating air, and blistering heat combine to create a death sentence unlike any other. On Venus, survival isn't just unlikely, it's impossible. It's a world that reminds us how delicate our existence is, and how uniquely suited Earth is to support life. Facing death on Venus means confronting an alien environment so hostile it defies human endurance, a stark warning of the dangers lurking in our cosmic neighborhood. Earth. Earth is the only planet we truly call home, but even here, death comes in countless forms, each a reminder of life's fragility. Unlike the other planets where death is swift and absolute, Earth offers a complex dance between survival and demise. From natural disasters like earthquakes and hurricanes to diseases and aging, death here is often a drawn-out process, filled with struggle and sometimes peace. Our atmosphere, rich in oxygen, sustains life but also carries invisible threats like viruses and pollutants. The diversity of ecosystems means death can come from a myriad of sources: predators, accidents, or even the slow decay of time. Yet Earth's protective magnetic field and breathable air make it uniquely suited for life to thrive, fight, and sometimes cheat death for a while longer. Unlike the crushing pressures of Venus or the freezing void of Mars, Earth's environment allows for hope, healing, and resilience. Death here is not just an end but part of a cycle that fuels new beginnings. It's a planet where life and death are intertwined in a delicate balance, making every moment precious. While the other planets offer harsh, immediate ends, Earth's version of dying is a complex, deeply human experience, sometimes tragic, sometimes beautiful, but always a testament to the extraordinary conditions that make life possible. Mars. Mars might seem like the most promising place to visit beyond Earth, but dying there would be a harsh and lonely ordeal. The thin atmosphere, made mostly of carbon dioxide, offers almost no oxygen, so without a spacesuit, suffocation would be swift and inevitable. Temperatures on Mars can plunge to a frigid -125 degrees Celsius at night, freezing exposed skin and organs in minutes. Unlike Earth, Mars lacks a protective magnetic field, leaving its surface bombarded by deadly cosmic and solar radiation that would damage your cells and accelerate death. The planet's dusty environment, with frequent dust storms that can engulf the entire planet for weeks, would make breathing impossible and blind any hope of escape. Even if you survived the initial lack of air and freezing cold, the relentless radiation and isolation would make death certain. Mars has no liquid water on the surface, no shelter, and no atmosphere to soften the blow. It's a barren wasteland where life struggles to exist, and death comes quickly and quietly. Facing death on Mars is a stark reminder of how uniquely Earth protects and nurtures life, and how unforgiving the cosmos can be beyond our fragile blue planet. Jupiter. Jupiter is a colossal giant, but dying there would be a violent and instantaneous ordeal. Unlike the rocky planets, Jupiter is a gas giant with no solid surface to stand on, only layers of thick, crushing gases. As you plunge into its atmosphere, the pressure would increase so rapidly that your body would be crushed like a tin can within seconds. The intense gravity, over 2.5 times that of Earth, would make every movement agonizing and suffocating. On top of that, Jupiter's atmosphere is filled with deadly radiation belts far stronger than Earth's, capable of frying your cells and nervous system almost instantly. Violent storms rage across the planet, including the famous Great Red Spot, a storm larger than Earth that has been raging for centuries, with winds reaching hundreds of miles per hour. There's no hope of survival in this swirling chaos, no solid ground, no breathable air, just a crushing, radioactive storm that would obliterate you long before you could even realize what's happening. Dying on Jupiter is a brutal reminder of the raw, unforgiving forces that dominate the gas giants, worlds so alien and extreme that human life simply cannot exist. It's a death that's swift, violent, and utterly merciless, highlighting the stark contrast between Earth's hospitable environment and the hostile vastness of our solar system. Saturn. Saturn's breathtaking rings might captivate your imagination, but dying on this gas giant would be a nightmare beyond comprehension. Like Jupiter, Saturn has no solid surface, just thick layers of hydrogen and helium gas, crushing everything beneath with unimaginable pressure. As you descend, the pressure would increase so rapidly that your body would be flattened and crushed in moments. The atmosphere is toxic, offering no oxygen and filled with deadly gases that would suffocate you instantly. Violent storms rage across the planet, with winds reaching speeds of over 1,800 kilometers per hour, battering anything caught in their path. The cold temperatures and crushing gravity would leave no chance for survival, while the intense radiation belts would fry your cells in seconds. Even the iconic rings made of ice and rock offer no refuge. They are a dazzling but deadly barrier circling this hostile world. Dying on Saturn means being overwhelmed by crushing pressure, toxic gases, and relentless storms. A stark contrast to the calm and life-sustaining environment of Earth. It's a brutal end on a planet that looks beautiful from afar but hides a violent and merciless reality beneath its shimmering facade. Uranus. Uranus is a world of icy mystery, but dying there would be a chilling and merciless experience. Its atmosphere, a toxic blend of hydrogen, helium, and methane, offers no oxygen and would poison your lungs instantly. Temperatures plunge to an unimaginable -224 degrees Celsius, colder than any other planet in the solar system, freezing exposed flesh and internal organs within moments. The planet's extreme winds, reaching speeds of up to 900 kilometers per hour, would batter your body relentlessly, tearing at any protective gear or suit. Unlike the fiery infernos of Venus or the crushing gas giants, Uranus kills with a deadly combination of freezing cold, toxic air, and violent storms. Its tilted axis causes extreme seasonal changes, but no season brings relief from the brutal conditions. Radiation levels, though less intense than Jupiter or Saturn, still pose a lethal threat over time. Death on Uranus is a slow, frozen suffocation, a stark contrast to the fiery or crushing ends on other planets. It's a silent, icy grave in the depths of space, reminding us how fragile life is and how uniquely Earth shelters us from such cosmic horrors. Neptune. Neptune is a planet of extremes where death would come in a violent and unforgiving storm. The atmosphere is a swirling mix of hydrogen, helium, and methane, creating a toxic environment with no oxygen to breathe. Temperatures plunge to a bone-chilling -214 degrees Celsius, or -353 degrees Fahrenheit, freezing any exposed skin and organs almost instantly. But it's the winds that truly define Neptune's deadly nature. Howling at speeds up to 2,100 kilometers per hour, these are the fastest winds in the solar system, capable of tearing apart anything in their path. The crushing atmospheric pressure would squeeze your body relentlessly as you descend, while the intense cold would freeze you solid. Unlike the gas giants closer to the sun, Neptune's storms are mysterious and fierce, swirling in a dark blue haze that hides the planet's lethal secrets. Radiation levels add another layer of danger, damaging cells and accelerating death. Dying on Neptune means facing a brutal combination of freezing cold, crushing pressure, toxic air, and relentless planet-wide storms. It's a death marked by chaos and silence, a stark reminder of how hostile the outer reaches of our solar system truly are. Neptune's beauty from afar masks a violent world where survival is impossible, and death is swift and merciless. Pluto. Pluto may no longer be classified as a planet, but dying there would still be a chilling and lonely fate. This distant dwarf world is a frozen wasteland with surface temperatures dropping to nearly -240 degrees Celsius, colder than any other place in our solar system. The atmosphere is incredibly thin, mostly nitrogen, with almost no oxygen to breathe. Without protection, you would freeze solid within moments, your body succumbing to the extreme cold and lack of air. Pluto's weak gravity and lack of magnetic field mean it offers no shield from deadly cosmic radiation, which would slowly damage your cells as you drift in the frigid darkness. The surface itself is covered in ice and rocky terrain, offering no shelter or warmth. Death on Pluto is a slow, frozen suffocation in a silent, desolate environment where time seems to stand still. It's a stark reminder of the vast, cold reaches of space and how uniquely Earth supports life. Far from the warmth and protection of the sun, Pluto is a graveyard of ice and silence, a place where survival is impossible and death is absolute. The Sun. The Sun is the ultimate force of destruction in our solar system, and dying there would be an instant and fiery end beyond comprehension. Temperatures on the Sun's surface soar to around 5,500 degrees Celsius, hot enough to vaporize any matter in seconds. As you approach, the intense heat would burn away your skin, muscles, and bones almost immediately, reducing your body to a cloud of plasma before you even reach the surface. The sun's gravity is so powerful that it would pull you in at unimaginable speeds, crushing and stretching your body in a deadly process called spaghettification. Beyond the surface lies the sun's core, where nuclear fusion powers its immense energy output, an environment utterly hostile to any form of life. There's no escape from the searing radiation pouring out in all directions, which would fry your cells and nervous system instantly. Death on the sun isn't just an end, it's a violent obliteration, a complete erasure of existence in a blaze of unimaginable heat and energy. It's the ultimate reminder that while the sun gives life to Earth, it also holds the power to destroy everything in an instant. Facing death on the sun is confronting the raw, unstoppable force at the heart of our solar system, a fiery grave that consumes all without mercy. Thanks for joining us on this cosmic journey through the final moments on every planet. If you enjoyed exploring these mind-blowing facts and want to dive deeper into the wonders of science and technology, make sure to subscribe to InnoVision Tech. Don't forget to hit the bell icon so you never miss an update from us. We'd love to hear your thoughts. Drop a comment below and tell us which planet's death scenario surprised you the most. Stay curious, and we'll see you in the next video.